Every right triangle has three sides, as does every triangle. The two sides which form the right angle are called legs. The legs may or may not be congruent. Unlike an isosceles triangle, the legs don't have to be congruent. The side that is opposite the right angle is called the hypotenuse. These are terms we've seen before, although I don't know that we've emphasized the term leg before. In the drawing at the top, ignore for a second the three triangles at the bottom, I've again drawn a right triangle, triangle XYZ, but I've added a new segment. I've added a segment which is segment YT. I've marked its length as G. Now, that segment YT is the altitude of triangle XYZ drawn to the hypotenuse. Remember, an altitude goes from a vertex, in this case Y, and is perpendicular with the line containing the opposite side. So it's perpendicular to XZ, which is the hypotenuse. If we give the two legs length A and B as shown, and the hypotenuse, XZ, is marked with length C, you'll notice that segment YT divides the hypotenuse into two parts. I've marked them here as E and F. There are now three right triangles in our picture. Down at the bottom, I've shown those three right triangles separately. The big right triangle on the outside, triangle XYZ, who has sides of length A, B, and C. There's also two small right triangles on the inside. They are YTZ and XTY. I've drawn them below, and I've transferred all the length information to those diagrams. Notice that the first two triangles, XYZ and YTZ, both contain angle Z. I've got it down here with two marks on it. Okay? That means because they both contain right angles, the first two triangles are similar by angle-angle. Also, if you will notice, the first triangle and last triangle both contain angle X, so they also are similar by angle-angle. Similarity of triangles is transitive, which means that all three triangles are similar to each other. Well, that means that we can form ratios of corresponding, we can form proportions using ratios of corresponding sides. So I'm going to write some of these proportions that are going to be important to us up top. As soon as I clean this all up. Okay. Using the two small triangles, the two ones that are drawn in red, I can say that F over G is equal to G over its corresponding part, which would be A. Oops, that's an error. The corresponding part to G would not be A, but rather would be E. So F over G equals G over E. Okay. We've got that's a geometric mean relationship. If you notice, that makes G a geometric mean. Okay, let's write a couple more that we can do in that way. If we use the first triangle and the second triangle, I can get the following information. I can say that F, if I circle that guy right there, F over B, which would be its corresponding part, is equal to B over C. And one more relationship I want to point out. I can get that using the triangle XTY on the far right and the big triangle. I can get that E right here over its corresponding part, A, is equal to A over its corresponding part, C. Now, what I'm going to do is I don't need those three triangles at the bottom anymore, so I'm going to get rid of those. But leave the one up top in those three proportions. Okay, the top proportion. Right there tells me that G is a geometric mean. Well, G is the altitude drawn to the hypotenuse. So if I call that number 1, there's a rule that we've got now. The altitude is the geometric mean between the two segments of the hypotenuse. And secondly, these second two proportions both deal with the legs of the original right triangle. Notice that B is a leg of the original right triangle, and so is A. They are both geometric means. What we'll see then is that, let's look at B. B is the geometric mean between F and C. What are F and C? F is the part of the hypotenuse that's next to or adjacent to B. C is the whole hypotenuse. Okay? So B is the geometric mean between the part of the hypotenuse next to it and the whole hypotenuse. Okay, well, look at A. A is the geometric mean between E and C. Well, what is E? E is the part of the hypotenuse next to or adjacent to A. And again, C is the whole hypotenuse. So we can write the same rule for both of those. In words, each leg is the geometric mean between the part of the hypotenuse, the book would use the word segment, HYP for hypotenuse, and, the part of the hypotenuse next to that leg, and the whole hypotenuse, which I'm just going to write and hypotenuse. Okay, we can use these two rules then to solve problems involving pictures that look like triangle XYZ with the altitude YT drawn to the hypotenuse. In the next video, we'll show you how to apply those rules, but these are the two rules that you need to know.